So in the left side, when you talk about energy efficiency, you have replaced inefficient lights with efficient lights. But in conservation, you turn off the lights and use the natural light, because natural light is free. Energy saving is, I think I said this earlier, but energy saving is a game of cricket. It is not a game of chess. It is not that only one person who is conscious about energy can save energy in a building. It doesn't happen. Every person who is occupying and using that building should be equally conscious and aware and taking actions to save the energy. Then only it will happen, otherwise it will not happen. So like 10 years back or 15 years back, CFL was regarded as the miracle, as the cure. Like all incandescent bulbs which are extinct now. I mean, incandescent bulbs now probably you will see it only in very rarely you will come across, not in use ever, but maybe sometimes somewhere. So CFL was hailed as the invention. Now CFL is also gone. Now LED lights are there everywhere because they are far more efficient. So maybe another 10 years from now, LED also will become extinct and something new will come. Now as a standard practice, any ROI which is between 2 to 3 years is considered as very attractive and good. Anything which is beyond 3 years is slightly doubtful and questionable by the management. They may or may not be interested. Anything which is less than 2 years is more than welcome. Now fixing a baseline is a safe thing. Normally it is for all the stakeholders. Here there are 3 stakeholders. One is the energy auditing consultant or the company whom you have invited. Second is you as an implementation team, and the third is the top management who wants to see results because they are spending money on this. So you have to fix a baseline. Now in this context also, it is not that if your energy bill is 6 lakh rupees per year, that you can allocate 50,000 rupees per year for 12 months. It doesn't happen like that. And all of us know this. I guess everyone knows this, but this is just to repeat in this context because it is very important. Sometimes we miss out on the small things. In the summer months, the bill will be as high as 2 to 2.5 times of the winter months. Because in winter months, your AC will be very less loaded. It may even be switched off for longer periods. Compressor may not run, only blowers might run. You take a lot of fresh air, which is already at a lesser temperature. Like there are some people are unreasonable in every organization. I know you will also have, everyone has some unreasonable people in the organization, but sometimes these unreasonable people are the ones who drive the organization towards excellence, because you can't achieve excellence unless you are unreasonable to a certain extent. So these people, the unreasonable people, will suddenly jump and they will say, sorry, the savings are not there in this month. Why there is no saving at all? So if you are, in the summer months, your bill is going around 70,000 or 80,000 rupees, and winter months it is around 20,000-30,000 rupees. You need to compare the bill of summer months with summer months and compare the bill of winter month with the winter month. June to June, December to December, February to February, and August to August. So the real emphasis on the energy efficient lights, energy efficient pumps, energy efficient compressors, these all came between 2000 and 2010, something like that. And then by 2015 or so, then it was generally as a standard. I mean, without any exception, unless there are very stingy people in projects who wanted to cut cost even at compromising buildings efficiency, whatever. But generally, all the equipments which are installed in the new buildings, relatively new, which is last 5-10 years, they are all efficient equipments. That means now, for example, if your pumps are efficient, they are with the VFD. If your compressor is efficient, if your lighting are all LED, what will you do? So if you need to save energy, then where is the opportunity for this? On a city level or country level, now these new buildings are handful. The existing buildings are too many. And the life of a building is typically anywhere around 50 years plus minus. So currently, if you say the buildings which are having the efficient equipments in them are only maybe 10%, 15% at the most. So what about the 85% of the buildings? Now you cannot completely demolish them and make new buildings and whatever for them. So for those, there is something called retrofit. So when you do the retrofit, the concept is that you even replace the existing inefficient equipments which are in good condition with something which is more efficient, which is available in the market. So if your energy, if your total consumption of units is 22.5 per square foot per year, then you are optimum. You are running your site in a very good, in a very nice, efficient condition. There could be hardly some more scope for improvement. There is always, because it is never 100% excellence you do not achieve. But you are good enough. You have got every reason to pat your back and say you are doing a good job. If you are spending more than this, then definitely you have got a good opportunity to save. Next parameter, the power consumption in AC. If it is 10 units per square feet per year. Now 10 also I have taken slightly higher, it is anywhere between 8 to 10, but you take 10 as a standard. Third parameter, the AC tonnage capacity that has been installed at your site, it should be anywhere around 500 square feet per ton or more, not less. If you are having, say, only for example say 300 square feet per ton or 400 square feet per ton, that means you have installed more tonnage of AC and you are using and consuming more AC in your building. Because the design teams, have got a typical habit that they always over design the capacities of all the equipments that are installed in building. And so what might happen is that they will install more and you will keep also running more, whereas it is not really very economical. The next is water consumption. It should be anywhere between 50 to 60 liters per person per day, because green building is the ultimate objective of any energy optimization exercise. The highest level of energy optimization when you do, it becomes a green building. By the way, there are different green standards all over the world. Like earlier it was only the LEED rating, the LEED platinum rating, gold rating and all that, which is the leadership in energy and environment design. But however, some of you might be surprised to know that there are around 30 or 40 agencies all over the world in different countries who are giving the certification. LEED certification is still there and that is still premium, but that is not the only certification agency in the world. For example, in India, we have got something called Griha, which is Ghar, the house. So Griha certification. So likewise, Singapore has got its own, Malaysia has got its own, Gulf countries, they have got their own. So these kind of different green concepts are there, but as a standard, all the green buildings generally, they are the 6 features that they have. The health of the occupants, the productivity of the occupants, the impact on the environment, these are all taken into consideration. That's why, as one of the trivia or the small amusing information about green building, for certifying as a green building, the construction material has to be a reused material. You cannot use new material, new bricks. A building cannot get a green certification if it uses new bricks from the market. Buy 5 truckloads of bricks and construct a building, it never becomes green. The construction material has to come from rubble, from somewhere some building has been demolished. Because the reason they say that if you are using new bricks, that means already so much of water, energy has been spent in making that brick and you are already using that. So it goes to the highest level of sustainability, where it says that you are not consuming any additional energy from the environment to construct this building. And the indoor environmental quality as well. Indoor air quality is something which is actually very neglected kind of area, which is not given more importance, but that's a serious concern. And it might come as a surprising news for you. We talk about lot of air pollution on the road and all this thing outside, but generally the air pollution or the indoor air quality in the house is worse than what is outside. This might come as a surprise. And further surprise is the indoor air quality in a car is even worse than even in the house. Now this is a slide showing the statistics of the current status of green buildings in India which are certified. So you will see that currently there is Maharashtra ranks at number 1, which has got 373 green certified buildings. So Maharashtra ranks at 1 with 373, Karnataka 301, then there is Haryana, Tamil Nadu, Uttar Pradesh, Telangana, Delhi, Gujarat, West Bengal and Rajasthan. Green buildings we are hearing for last 20 years, 15 to 20 years we are hearing. But net zero building is something which is in the last maybe 4-5 years we are hearing about it. Now what does net zero building say? In the simplest words, net zero building says that whatever energy is used in a building is generated in that building per year. As simple as that. Now we will see the top 5 green buildings in India. This is just for information sake. There is ITC Green Center which is in Gurgaon. Then there is Suzlon One Earth in Pune. Patni iGate Knowledge Center in Noida. Then you have Olympia Tech Park in Chennai. Infinity Benchmark in Kolkata. By the way, I assume everyone knows, but if someone doesn't know, just for information, that solar power doesn't mean that sun rays have to fall on the panel. No. Even if there is a daylight, it generates power. It produces energy. So it is not necessary that the sun rays has to be there on a cloudy day, it doesn't generate energy. No, it is not like that. Even on a cloudy day, the energy will be generated. It will be slightly lesser because of the clouds and the light intensity. And that's why on a peak summer, light will be highest, brightest light, so it generates more energy. but sun rays are not essential for generating power in a solar panel. Now, for example, meeting rooms, normally meeting rooms are fully occupied. There are some people who have got very fancy for meeting. They say let's call a meeting for nothing, just time pass, something like that. There are people of all types everywhere. So whenever the meeting room is empty, whenever there is no one there, then the lights and AC should not be running, and that can be controlled by using a motion sensor. All of us have heard about the Kaizen principle, the Japanese principle of Kaizen. Kaizen has got vast and different interpretations. My simple interpretation, I am not sure whether it is correct or not, or it could be one of the interpretation. It says that never try to do something big. Do small things consistently, and suddenly a big thing will appear in front of you. So likewise, if you want to save large amount of energy, don't look or don't explore to find out which one thing that I can do that will save me a lot of energy. No, it doesn't happen. What you do is find out everywhere you can save small amount of energy, save. And these all small things will add up to become a big number at the end of the day. How many of us get a daily report of the energy consumption on a daily basis? We don't get. Again, I feel if you are getting, you are super. You are an excellent person, you are efficient. If you are not getting, you can start getting it. It's like an expert doctor who just checks the pulse and says everything is fine with you, there is no need to study anything further. So average ATM has a connected load of 2 to 4 kilowatts, which is very low actually, very low unit. And out of that 2 to 4 also, majority is consumed by the AC which is installed in the ATM, which is not the ATM machine. The ATM machine is like maybe like 600 watts or 500 watts, which is like a TV or something like this. So currently the connected load, if you take all the lights, there will be at least 2 or 3 lights. There will be one AC, 1 ton or 1.5 ton split AC will be installed in that, and there is one ATM machine. So these are the standard loads. If there are multiple machines, then it can go to 3 kilowatts or 4 kilowatts as well. So this is the average connected load for ATM. In this context, again, it makes sense to discuss here that if your office, this particular premises is small in the sense there is no chiller, and you have 4, 6 or 8 or 10 window ACs or split ACs, then this is a perfect case for energy saving, where you can replace those split ACs or window ACs with VRF system. Because VRF system, as we discussed earlier, it's a variable refrigerant flow, where in simple words, VRF system has got one outdoor unit can control 4 indoor units, even sometimes 6 based on the size. I mean, some companies come with a larger outdoor unit which can control 6 units inside.